Apollo 8, Houston.
Go ahead, Houston, Apollo 8.
Okay, we've got a telescope alignment if you would like to give it a try. Your sextant star is still good, but if you have problems with that, folks have worked out that if you look through the telescope at 1035, we have a shaft and trunnion that should point you at the center of the Earth, if you'd like to give that one a try.
Okay.
Okay, at 1035, the shaft angle 006.2. Trunnion 18.9. Over.
Roger, 1035, shaft 006.2, trunnion 18.9.
That's affirmative. Apollo 8, Houston.
Go ahead.
Okay, we'd like to get a cryo fan cycle in here before the burn. About 1 minute on each would be fine.
Roger, I'm only given 2 minutes on H2 1 and 2 and O2 1. I just started O2 2.
Roger, thank you. Apollo 8, Houston, we'd like to dump your tape prior to the burn.
Roger, it's only been running here about 15 minutes.
Okay, Apollo 8, that's correct. You're on high bit rate, and we're afraid you may run out before the burn, so we'd like to dump it and give it back to you with a full load before the burn.
Roger, and give us a comment on the voice quality.
Wilco.
Houston, Apollo 8.
Go ahead.
Roger, we plan to stop charging battery D about another 5 minutes. You concur?
That's affirmative.
Okay, you might just remind us.
Wilco. Apollo 8.
This is 8, go ahead. Go ahead, Houston, you were cut out.
Okay, Apollo 8, all your systems are go, and we were about to tell you could go ahead and terminate the battery charge, and you beat us to the punch.
I read your mind, and it's showing 37 volts right now.
Okay.
This is Apollo Control at 10 hours 45 minutes into the flight of Apollo 8. At the present time, our spacecraft is at an altitude of 51,595 nautical miles, traveling at a velocity of about 8,300 feet per second. Flight Director Milton Windler has just gone around the room here in Mission Control Center, reviewed the status of the spacecraft and flight for the first mid-course correction burn, and we've passed up a go to the crew for that maneuver scheduled to occur in just about 15 minutes from now at 11 hours ground elapsed time. That burn will be a very short one, about 2.4 seconds. It will add about 24 or 25 feet per second of velocity to the trajectory. Most of that will be in a posigrade direction, velocity added rather than velocity subtracted. And there will be also some minor direction change in it, but most of the velocity is an increase. At the time of ignition, the spacecraft will be at an altitude of about 52,770 nautical miles. We do have a recording of some conversation with the crew over the past 15 or 20 minutes. We'll play that back for you now and then stand by to monitor any conversations that develop. This is Apollo Control. We've had a relatively quiet period for the last few minutes between the ground and the spacecraft, and we imagine that the crew is rather actively involved in making final preparations for their first mid-course correction en route to the moon. That engine ignition is now scheduled to occur about 2.5 minutes. Correction about 6.5 minutes from now at 11 hours ground elapsed time. The batteries on board the spacecraft have been fully charged up. They will be brought on the line during preparation and during the burn to assist in carrying the electrical load at that time. This is a normal procedure during a maneuver where the entire guidance and navigation system is required. We'll stand by to monitor the burn, pick up any communications with the spacecraft as we go through the final systems checks and await that mid-course correction.
Apollo 8, Houston. If you'll put your high bit rate on, we'll give you the tape recorder back.
Here in Mission Control, the guidance officer has just advised the flight director that the spacecraft gimbal motors positioning the SPS engine are in the proper attitude, and everything looks go for the burn, scheduled to occur now in about 3 minutes. We'll continue to monitor for conversation with the crew.
Affirmative, Apollo 8.
Apollo 8's command reset to get tape motion. We're now normal.
Roger. Apollo 8, stand by for a mark at 1 minute.
Roger,
10
Apollo 8,
seconds.
standing by.
5 seconds. 2, 1, mark. 1 minute.
Roger.
We're now 30 seconds from ignition of the SPS engine for that 2.4 second burn. That maneuver will be primarily to control the altitude of the spacecraft as it goes around the backside of the moon at perigee. Targeting there is for 60 nautical miles. 10 seconds now to the burn. 5, 4, and we have confirmation of SPS ignition. The thrust looks nominal, says the flight dynamics officer. And we should have shutdown also. We'll have confirmation of that shortly. And the guidance and control officer advises the flight director the burn time was 2.4 seconds, exactly nominal, just what was planned. That should have given us a velocity increase of about 24 or 25 feet per second. We've now taken the batteries off the line. Their job done in assisting carrying the heavier than normal electrical loads during a major maneuver of this sort, even though a very short maneuver. They will then be recharged to bring them up to full charge for the next maneuver or use of the SPS system. The initial indication was that the surface propulsion system engine, which all ground testing and previous flights has shown to be extremely reliable, and it appears to have demonstrated that reliability once again in this ignition, the first time that engine has been used on this mission. Of course, the flight controllers here in Mission Control Center are monitoring very closely the performance of the engine, and also happy to have this opportunity prior to inserting the spacecraft into lunar orbit. Of course, that is the engine that would be required to put the spacecraft into lunar orbit and also to take it out of lunar orbit and send it back to Earth. At 11 hours 2 minutes, this is Apollo Control.
Houston, Apollo 8.
Go ahead.
Roger, the burn time was on time, about 2 seconds. We had residual of 4.4 in X. We burned it out to 0.2. Attitudes were nominal. The delta VC before the residuals were taken out was a minus 2.4. I have transferred the state vector to the left slot with bird 66.
Roger. Copy 4.4 for X and 2.4 on Z, and negative residual on Y prior to trim. Is that affirmed?
That's affirmative, and we took out the 4.4 residual down to 0.2.
Roger.
Houston, Apollo 8, you want us to start charging battery A now?
Stand by. Apollo 8, let's go back to battery Bravo, and we'll finish that one off before we start in on Alpha.
Roger. Battery Bravo. Houston, Apollo 8, you want us to maneuver to any particular attitude for a water dump, or you want us to go to the PTC attitude?
Okay, let's go PTC.
And give me the angles, please.
Okay, Apollo 8, let's use the same angles we had before. That's pitch 242 and yaw 20 on the PTC attitude.
242, yaw 20, roger.
Apollo control at 11 hours 8 minutes. And we've just gotten a preliminary assessment of the performance of the SPS engine from here in Mission Control Center. And from the indications of the burn, the SPS looks to be completely go, in the words of the guidance officer. And the other flight controllers also concur. The burn was completely nominal in all respects. We also had a post-burn report from astronaut Jim Lovell aboard the spacecraft, and we'll play that back for you now and then stand by for any further communications with the spacecraft. During that conversation, you heard Jim Lovell refer to the residuals. This is the amount of velocity remaining to be added or taken out of the trajectory following the ignition of the SPS engine. And we normally expect a small residual. We did have residuals of about 4.4 feet, according to Lovell. And as per their normal procedure, these were removed by burning the reaction control system thrusters. A very short duration burn on those to, in effect, peak up the effects of the burn and put the spacecraft velocity right on the pre-planned. At this time, Apollo 8 is at an altitude of 53,200 nautical miles and traveling at a speed of 8,134 feet per second. This is Apollo control at 11 hours 12 minutes into the flight.
Where the pressure would drop rapidly to this setting as if it was zero. Over.
All right, we'll look at our data here and let you know what we see. You going ahead with the water dump now?
Roger, we're pausing here on the water dump, though, just to verify that the battery vent, the line is clear as indicated by a battery vent pressure of 0.
Okay, stand by then. Apollo 8, Houston.
Go ahead, Houston.
Okay, number one on the list of things is that the flight plan shows the CDR should hit the SAC. Number two, kind of a summary of your burn. All your SPS and systems look go. The trajectory shows that you have a CPA with the moon of 69.67 miles, and the time of percentium is 69 plus 10. You do have capture on a good free return. It's a little bit early to completely evaluate the trajectory for corridor control. You'll have no update to the TLI plus 11 block data. After looking through the cal curves, it looks like the battery vent pressure is actually 0 at 0.2 to 0.3 volts. So that we agree with you there, and you can go ahead with the water dump. We still have the comm check to do whenever we get ourselves into a good high gain look angle and whenever it's convenient for you. Over.
Thank you very much. That was a very fine resume, Houston, and we're right now in the process of trying to dump out the water and the UCDAs and so on, so we'll get with you on the high gain as soon as we can.
Okay, good burn.
Houston, what do you want to dump the waste tank down to?
Apollo 8, I'd like for you to dump the waste tank to 25%.
Okay. And we're dumping now, Houston.
Okay, thank you.
We finally got some stars to see.
This is Apollo control, 11 hours 30 minutes into the flight of Apollo 8. We have some further refinements on the results of that service propulsion system midcourse correction, the first midcourse correction planned en route to the moon. The effect of the burn was to give us a parasynthion, or low point, closest approach to the moon, of 69 nautical miles. We'd been targeting for about 60 nautical miles. This information, of course, will be evaluated further and refined. This is the preliminary flight dynamics officer analysis of the effects of the burn, and we would expect some update to that. The burn also gives us a time of closest approach to the moon of 69 hours 10 minutes ground elapsed time. The pre-flight analysis had placed that time at 69 hours 7 minutes, or just 3 minutes different from what we have as a result of the translunar injection and the subsequent midcourse correction. There are 4 midcourse corrections nominally planned in the flight plan, all of which or none of which could be used en route to the moon. And depending on the results of the final analysis on the results of this burn, it would be decided whether or not subsequent midcourse corrections would be required. We would anticipate that any subsequent corrections would be quite small. We also had a brief communication with the spacecraft in the last few minutes, and we'll play that back for you now.
Apollo 8, Houston.
Go ahead, Houston, Apollo 8.
Roger. Do you folks have your water quantity switch in the potable or the wastewater tank position now?
We're in the waste tank position now, and we're dumping the UTCAs first, Houston.
Okay, we weren't watching any waste quantity decrease. It looked like the nozzle temps indicated that something was going out, and we were trying to dope out what was going on.
Well, there's a lot of stuff going out, I'll tell you. How the nozzle temps look?
Oh, about 81.
Okay, we'll keep on going here.
Airman.
Communications continues to be excellent with the spacecraft. We're continuing to track with the 85-foot dish antenna at Goldstone, California. The crew reported earlier that the signal strength indication that we had was above normal, above what they would expect, and up to this point we have had extremely good results from the unified S-band communication system. The spacecraft is presently about 50,000 nautical miles from Earth, as shown on the large plot board here in the front center of Mission Control Center. We expect the crew will begin a series of relatively relaxed activities aboard the spacecraft. Commander Frank Borman, after a very long day, is scheduled to have a 7-hour sleep period, and he should be in that sleep period at the present time. Following Borman's sleep cycle, Lovell and Anders will get their sleep period in about another 6.5 hours. At 11 hours 39 minutes, this is Apollo Control.
Okay, Houston, we're going to dump the waste tank on down to about 25%.
Okay, thank you.
Houston, Apollo 8, do you copy?
Affirmative, Apollo 8.
Okay, tell the ECOMs to wake up and keep an eye on the waste tank servicing.
That'll take a minute to think of something appropriate.
You're slowing down.
So are you guys.
How the nozzle temperature's looking, Houston?
Stand by.
Yeah, you're looking pretty small down there now, Houston.
We're carrying a big stick, though.
Just barely got clear lake.
And your nozzle temperatures, Bill, have dropped from about 94 to around 66.
Okay, I'm showing just a little bit above 50% here, and we'll keep on going. If it looks too cold, give us a call.
Okay, we'll do that.
Houston, we had a momentary O2 high flow, but we think it's due to all the purging of the water lines we're doing here in the cabin.
Roger, we concur. Apollo 8, Houston, we show you're down to 25% of your wastewater.
Okay, I'm about 28, Houston, stand by just a bit. Okay, waste dump stop and then purge again.
Understand, waste dump stop.
Roger. Houston, we're on a high gain, and it might be a good time to try your comm check.
Apollo 8, we're going to go ahead and crank up for the comm test now. And we will be a little bit late on your update for 12 hours.
Okay.
Do you still want to have us command as much as we can on the ground, or would you like to move the switches yourself?
Oh, you can have the fun of doing it.
Sound like you're dragging there.
Say, Houston, just to verify, we're using 1/250 of at F11 on CEX and C-mags for Earth shots. You verify, over?
Okay, you got going for it. I got my pencil up. How about saying it again?
F11 at 1/250th for CEX 16 millimeter and C 70 millimeter.
Okay, thank you.
How about running that by the back room, boys? That meter doesn't be helping out too much.
Okay. Okay, Apollo 8, we're starting in setting up for our first comm test. This is going to be an uplink voice ranging and full downlink, which is not anything really different than what you have on board. I'd like for you to verify that the S-band normal mode voice switch is in place.
Roger, boys.
Okay, and the up telemetry data to data.
Roger, data.
Up telemetry command in normal.
Roger, normal.
High gain antenna to auto track. Correction, that's
auto wide beam, and you can go ahead and dump the tape.
Okay, I'd like for you to go to narrow beam.
Okay, going to narrow beam now.
Right. Ken, I'll give you a call when we get ready to work on the tape.
Okay, we're still in PTC, so you're only going to have it for about 10 or 15 minutes.
Okay, we've had some problems with our displays, and I think they're straightened out now, but you may have to keep us advised that we run out of limits in case we lose our display again.
This is Apollo Control at 12 hours and 4 minutes into the mission. The flight of Apollo 8 continues to progress very smoothly at this point. Both here in Mission Control Center and in the spacecraft, things have quieted down considerably since that mid-course correction maneuver. At the present time, Commander
while we're standing by here, Apollo 8,
7-hour
the
sleep
source
period.
module quantities that we have listed, we're going to try to update them. If you want to
Jim Lovell,
call down your
Bill Andrews
quantities,
are currently
have you
involved
checked them with your
primarily
charts?
in some housekeeping functions aboard the spacecraft, managing the system,
They haven't gotten around to that.
and also
Okay, there's no hurry on it.
communications
Just
with
wondered if you had
the
done it.
group
We'll
that are
check it
involved in
against
taking
what we get on
pictures.
our nomogram.
We have several minutes of accumulated tape on communications with the spacecraft over the past 30 minutes, and we'll play that back for you now.
I'm showing a SPS helium pressure about 3570 indicated on board.
All right.
And fuel and ox tank pressures are 177 and 176 respectively.
Okay.
N2A is 2400, B 2500.
Okay. Okay, and the back room tells you that you've got the right f-stop.
Okay, I will keep using it. This PTC attitude really isn't the greatest for taking pictures of the Earth.
Right.
Or the moon.
Apollo 8, kind of stand by for a burst of noise as we change configurations on the ground. We're going into test 1. You'll still have up and down link. And we'll be in this mode for 2 minutes, but you may hear some burst of noise as we change.
Roger.
Okay, Apollo 8, we're in the middle of our first test, and how about giving me a voice check?
Roger, Houston, this is Apollo 8. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Apollo 8 out.
Rog, and read you loud and clear. This comm is unbelievably good.
Good.
Okay, Apollo 8, we've finished the first test, and we're now going to change the uplink mode to uplink command and ranging, and we'll be going without up voice. We'll be in this mode for 2.5 minutes, and we'll be sending a test message. It'll have no effect on either your computer or your panel switch configuration. What you might see will be the S-band noise that's associated with a brake lock. However, you should still have a good signal on your power meter. This is not a loss of signal, but rather just a loss of the voice modulation. And I'll give you a mark just before we do that so that you can turn your S-band volume down if you so desire. And we'll be back up in this mode we're in now in 2.5 minutes.
Roger.
Apollo 8 Houston, we're about to disable the voice modulation on uplink, and we'll be back up no later than 12:13.
This is Apollo Control at 12 hours 14 minutes into the mission now. Apollo 8 is presently some 58,000 nautical miles from Earth, 58,334 according to our displays here in Mission Control Center. And the spacecraft is traveling at a velocity of 7,700 feet per second. We do expect probably for the rest of the night we'll have a rather quiet period here in Mission Control Center. The commander, Frank Borman, is
Apollo 8 Houston, voice check.
sleep period now. He should be about 1 hour long. Following that, we'll have sleep periods for command module pilot
Apollo 8 Houston,
and for lunar module pilot
Roger,
Bill
Houston,
Anders.
read you loud and clear. How many?
Most of
Okay,
the
loud
tests
and clear. We're back up
throughout
with you.
the night,
Completed a second test.
at least night here in Houston. Will
Okay.
be housekeeping chores. There will also be an eat period for the command module pilot and lunar module pilot before they begin their sleep period.
Okay, our next test will be a test of the uplink
they'll be
voice
doing
and
some
ranging with
navigation
downlink
exercises
voice
on
ranging and
board.
low bit rate. So we'll be changing your bit rate on you.
And primarily
And we'll be making a voice check in the middle.
doing housekeeping chores aboard the spacecraft.
Okay, you're about to add it on the high
At
gain.
12
you
hours,
might try to get
15
in,
minutes
but it's,
into the flight.
it's going
This
to
is
hit the speed
Apollo
limit
Control.
here any second.
Okay, Apollo 8, looks like we'll get our information before we lose the high gain.
Okay, we'll just leave it go. Well, we got the scan limit. We'll let go, Houston, and till it breaks lock.
Okay, Apollo 8, go ahead and switch to the Omni.
How are you done with your test?
Okay, we've got 3 steps of the test, and we'll have to pick up the rest next time we get a look at the high gain.
Okay.
Houston, Apollo 8.
Go ahead, Apollo 8.
Roger, running out P21 at 269.10 indicates a parallel of about 67.4 miles. I guess we concur here.
You guys are getting pretty good.
That's a lot better than our first answer.
We don't care if we're right, just so MDAT is right.
Houston, Apollo 8.
Go ahead, Apollo 8.
Roger, I'd like to ask a question about this TLI plus 11 maneuver that we copied in the remarks. You have P37 Delta V 7900. Is this the Delta V that we would use with P37?
Okay, that's the option that you use with minimum time.
Roger, what I'd like to do is check out our P37 with your TLI maneuver update.
Okay, Apollo 8, I'd like to make sure we don't have a misunderstanding that the 7,900 feet per second is the Delta V. It's not associated with a high-speed workaround procedure. This is just a standard P37 Delta V.
Roger, but was that the Delta V that you used to give us the TLI plus 11 pad? Okay, I see. Never mind.
Okay, that's not the one that the maneuver pad was based on. That's the number you'll put in for the minimum time.
Roger, I understand.
Okay, and there sounds like a good idea if you want to go ahead and check out the 37. And we're standing by to work on comm as soon as that high gain is available.
Roger.
Okay, Houston, you got the high gain.
This is Apollo Control Houston at 12 hours 45 minutes into the flight. At the present time, Apollo 8 is just beyond 60,000 miles from the Earth, 60,536 nautical miles. And the spacecraft velocity is continuing to decrease gradually. At the present time, the speed is about 7,500 feet per second. During the past 30 minutes, we recorded about 5 minutes of conversation with the spacecraft. We'll play that back for you now.
Houston, do you read Apollo 8, over?
Apollo 8, Houston.
Roger, the high gain is yours.
Okay, and if you're ready, we'll go ahead with our comm checks.
Go ahead.
Okay, we're starting in now on our 4th test. I'd like for you to put your telemetry inputs switch to PCM high.
Too high.
Okay, and now we're going to switch uplink to the up voice backup for about 2 minutes. And may take a couple of seconds when you hear the up voice lost. So you can place your up telemetry data switch to up voice backup. And in the event that all of this doesn't work out too well, I'm reading 12:47 on the clock now. And let's meet back in our present configuration no later than 12:50.
Roger, going up, voice backup.
Okay, thank you. Apollo 8, Houston.
Roger, Houston, read you loud and clear.
Okay, that's pretty good. That's up-voice backup. And would you confirm that you're in narrow beam on high gain?
Roger, narrow beam.
Okay, thank you. We're going to continue tracking and watching the high gain antenna here for a couple of minutes. And I'll give you a call when we're ready to go back.
Roger.
Apollo 8, Houston, we've completed this test. We'll be switching back to the full uplink. When you hear the noise associated with the loss of modulation, you can go back to the telemetry data switch to data.
Ready. Apollo 8.
Okay, loud and clear.
How's everything looking down there?
Real fine. We've got one to go here. If you'll put your telemetry inputs PCM switch to low.
Roger, going low.
Okay, we'll be in this configuration for about 2 minutes, and then we'll be completed with the comm test.
Roger.
I have some service module RCS quantities. If you'd like to take them sometime and check them against your onboard calculations.
Stand by. Roger, ready to copy. Could you give them quad A, B, C, and D in that order?
Okay, will do. And I'll give you the weight in pounds and the percentages. Quad A, 231 for 76%.
Roger, stand by. What time is that for?
Oh, 12 plus 15.
Okay, got it.
Okay, Quad Bravo, 251, 82%. Quad Charlie, 240, 79%.
Slow down.
Quad Delta, 245, 81%. GNC advises that these numbers are still good, even though it's a 12:15 time. And we're completed with the comm test. You can take your high gain antenna and go back to medium. Apollo 8, we'd like to dump your tape again if you're not using it. And the reason we want to do this is we had some that we didn't completely get dumped before the burn, and we'd like to get that and get the rest of the burn data. If there's no hurry on it, we can do it whenever it's convenient for you.
You got it.
Okay, thank you. Apollo 8, Houston, do you call?
Negative. Negative, Houston.
Okay, thank you. Say, we're curious what you did about your May West.
We thought we might bleed the CO2 out into the vacuum connector here on the next water dump. We forgot it last time. Did you copy?
Raj, doesn't seem like there's any problem with going ahead and dumping it in the cockpit if you like.
It is CO2, isn't it?
That's firm. Apollo 8, Houston, rehashed it again, and it looks like no problems at all with going ahead and bleeding it down in the cockpit. And then if you need it again on entry or after entry, well, we can blow it up with oil tube.
All right, I understand.
Apollo 8, Houston. Apollo 8, Houston. Apollo 8, Houston. Houston. Houston, is Apollo 8. We need you loud and clear. How is it? Okay, loud and clear now. Didn't get you there for a while. We were reading you all along, Houston. Roger, did you attempt to transmit, or were we just not getting through? Roger, we attempted to transmit. It sounded like you had a stuck mic down there for a little while. Okay, that shouldn't make any difference to us on this duplex mode. Okay, what I was calling for, Apollo 8, so we've got a maneuver pad that's TLI plus 25. I'd like to read up to you when you're ready for it.
Go ahead, Houston, TLI plus 25.
Okay, TLI plus 25. And this will be an SPS GNN. 63087. Minus 162 plus 129er 027 56 29er 64 minus 00163 plus 00001 plus 52759er 177 137 001 November Alpha plus 00201 52759er 623 52543 142347 337 023 up 195 left 17 plus 1145 minus 16500 127 80 358 90 074 3816 North Stars 068 097 356 no wellage. For the fast return P-37 Delta V 7900 to the Indian Ocean. High-speed procedures are not required. Over.
Houston, Apollo 8. Maneuver pad as follows. How do you read? Over.
Loud and clear.
Roger. TLI plus 25. SPS GNN 63087 minus 162 plus 129 027 56 2964 minus 00163 plus 00001 plus 52759 177 137 001 not applicable plus 00201 52759 623 52543 14 2347 337 023 up 195 left 1.7 68 097 356. No LH. P-37 fast return of 7,900 Delta V. Indian Ocean. High speed not required.
Oh, that's correct, Apollo 8. And we'll have a couple of more things for you before too long. We're working on a flyby pad at this time. And we're going to be talking some more to you about the problems of looking at stars in the sextant and the telescope. And what we'd like to do as soon as the black team comes on the motor, while we have two teams here, we'd like to get a rehash from you on exactly what you see and what you don't see and under what conditions, and see if we can define it so that everyone here understands what you've been telling us. And if you have any comments concerning the timeline, knowing that we got off our timeline before the burn, if you have any comments about that method of getting back on schedule, why, we'd like to hear those too.
Roger. We have one request. CDR would like to get clearance to take a signal.
Okay, Apollo 8, that's a go.
Roger.
And Houston, this is 8. We might go over our future nav sighting schedule if it's going to be revised at all.
Okay, Apollo 8, there are no planned revisions.
Roger.
This is Apollo Control at 13 hours, 16 minutes into the flight. We're in communication now with the spacecraft, and we have some accumulated tapes of previous conversation during the past 30 minutes. We'll play back the tape first and then pick up with whatever conversation is going on when we finish.
Apollo 8, Houston.
Go ahead, Houston.
Okay, have your flyby pad now, so I can give that to you whenever you're ready for it.
Stand by. Ready to copy.
Okay, Apollo 8, here we go on a flyby maneuver pad. This will be an SBS GNN 63087 minus 162 plus 129er 060 59er 4804 plus 009er 62 plus 005 68 minus 02077 000 000 November Alpha plus 00202 02359er 022 02282 03 0399er 314 013 up 048 right 37 plus 1418 minus 16500 129er 04 361 60 146 2911 North Stars 6323 090 056. No ullage. Remarks? Number 1, this requires realignment to preferred rest mat. 2, this will raise the paraloon to 550 nautical miles. Over.
All right, you ready to read back?
Go ahead.
Flyby SDS GNN 63087 minus 162 plus 129er 06059er 4804 plus 009er62 plus 00568 minus 02077 000 NA. Are you with me so far?
Keep going.
Plus 00202 02359er 022 02282 03 0399er 314 013 up 048 right 37 plus 1418 minus 16500 129er04 36160 14629er11 north 323 090 056 no ullage. Realign preferred rest mat at para G is 50.
That's a paraloon to 550.
I understand 550.
That's firm, and that's paraloon.
Right.
Follow 8, Houston.
Go ahead, Houston.
Okay, we've completed the dump, and the tape recorder is yours. And we've listened to the quality of the voice playback, and you have been given a go for your first test in creative writing.
Roger. Are we in low bit right now?
That's negative. You're in high bit, and you understand it's your tape recorder.
Now, Roger, you going to be staying in high bit all along, or are you going to be back in low here soon? Not that it matters much to us, really.
Okay, we plan to stay in high bit rate. We were going to ask you if it made any difference, and you read our minds. That's pretty good for 63K.
Right. That's an altitude record for mind reading.
Houston, Apollo 8.
Go ahead, Apollo 8.
Roger, onboard calculations indicates that at 13 hours and 30 minutes GET, we are now 64,200 miles above the Earth. That's using Aldrin's slide rule.
We've got 63,855.
Yeah, Houston, this is Apollo 8. We're going to try to keep the conversation down here for a while so you aren't going to sleep.
Okay, we would like to get some comments from you before you sign off concerning the telescope and sextant, and a verification that you have done something with the CO2 in your May West, and a comment on the window status.
Roger, is it a requirement that we do something with the CO2 at this time, over?
Oh, that's negative.
Roger, we have maintained the same condition. We have left it as it was, and we'll take care of it later.
Okay.
let me at this time go over the comments about the navigation as I see it so far.
Go.
In the beginning, the operation with the S4B precluded a immediate starting up of our sightings as we had scheduled, since we had another evasive maneuver. The dumping of the S4B caused a tremendous amount of pseudo stars in the area, which made a optics calibration practically impossible. The method which we had worked out does not seem to work too well. The method which I finally used was to go into P23, go to Sirius, which was our brightest star, get the shaft and trunnion, and then fly the spacecraft up to Sirius to use that for the optics cal, which we did at a later time. With regards to light scatter, it appears that at almost any attitude during our passive thermal control, we are receiving light scattering in the scanning telescope. It takes the form mostly of a wide band of light right across the center of the scope, about 10 degrees unit direction of 0. It's very difficult to see stars in this area. The realignments have been good. I have been able to pick up the star in the sextant to do the alignment, but I was not able to identify the star which we used in such cases as Regor or Mencken in the scanning telescope. The first star sightings of which I took of the Earth showed a very indistinct horizon, but there did appear to be a very, or somewhat sharp line between what appeared to be the Earth's horizon and the atmosphere. The landmark line of sight filter appeared to help out this horizon definition. There is a very hazy and indistinct horizon, though, between the space and the top of the atmosphere itself, and this is a very difficult one to use. As I said before, at times looking at the moon with the sun in the near vicinity, the area around the moon, the space around the moon, is not dark, but appears as a light blue. And this is also the same case looking through the sextant doing alignments with the sun in somewhere in the vicinity of the optics. However, I had no difficulty finding the stars in the sextant. I also had no difficulty spotting the stars I used, such as Sirius, Procyon, or Canopus, against the Earth during our star horizon measurements. I could see all three of those stars against the Earth background. I believe it would be very difficult to do a backup GDC alignment using the north set stars, since the Navi is not too bright of a star. I was able to spot star constellations in the scanning telescope if they were very bright and well known, such as Canis and Orion, stars of this nature. I was not able to perceive other constellations. That's about the only comments I have at this time, over.
Okay, fine. Thank you very much.
We are going to do, Houston, future maneuvers for P23 in a lower, or in a slower mode of auto maneuver. Essentially, we're going to load the DAP with 11101 to save fuel.
Roger, it'll be a 11101 DAP load.
Roger, we're going to try to save fuel that way.
Good show.
With respect to the windows, Houston, windows 1 and 5 have moderate haze on them, satisfactory for visual observation, but possibly not for photography. Windows 2 and 4 are clear. Windows 3 is almost opaque. Over.
Okay, thank you.
And how's battery B looking to you?
Apollo 8, Houston. Looks like it may take another 6 hours on this battery B charge. Turns out that the charge rate is less than what we were getting on our ground curves, but it's still above the Apollo 7 curves, and looks like it's going along in good shape. And I would like to have verification that the timeline leading up to the midcourse correction was satisfactory from your point of view.
Right, you're saying quite satisfactory.
Okay, thank you. And we'll stay off the loop until you give us a call.
Roger. You don't bother us, but our replies make a lot of noise.
Okay.
This is Apollo Control. During that rather lengthy series of conversations with the spacecraft, we heard Commander Frank Borman request permission from the ground to take a Seconal tablet. That is a short-acting sleeping pill. Frank was scheduled to begin his sleep period at about 11 hours GET, or about 12 hours, rather about 2 hours 45 minutes ago. We also, during that pass, heard a number of sequences of numbers passed up to the spacecraft. This is part of the block data updates that are routinely sent up at specified periods in the flight plan, so that the crew always has on board data that they can use in the computer to re-enter or to return to Earth should it be necessary for any reason, and assuming that they did not have communications with the ground. At the present time, Apollo 8 is at an altitude of about 64,600 nautical miles. The speed on the spacecraft is continuing to decrease more slowly now as we move farther from the Earth. That velocity at the present time is reading 7,236 feet per second. At 13 hours 44 minutes into the flight, this is Apollo Control.